Kia ora Year 12. This is Partial Fractions video 5 for Cambridge A-Level, and this is just one example of the kind of problem I did very, very slowly in Partial Fractions 4. So in this one I'm just going to get straight into it. We need to split this up into two fractions. One has x minus 4 as a denominator, and one has 3x squared plus 7. Right, now what we need to have here is we're going to have a constant term here, but we need to have a linear factor here. The reason we need to do that is to generate this term times this term is going to give me an x squared, right? So this times this is going to end up getting me a quadratic, which is what I need, because when I multiply my 3x squared plus 7 times my constant, I'm going to have an x squared. Okay, so that's where we're going. So once we've made that decision, everything else is pretty straightforward. We cross multiply, as usual, multiplying everything through by the denominator, and we get 29x minus 6 is equal to a times 3x squared plus 7 plus, and I'll try and squeeze this in, x minus 4 times bx plus c. There. Okay, so we're going to use a combo of our two methods, substitution, which is usually the fastest one to go to, and then matching up coefficients. So we're going to sub in x equals 4. So here we get 29 times 4 minus 6 is equal to a times 3 times 4 squared 16 plus 7 plus 0 times ... That gives me 110 is equal to 55a. So we can see that a equals 2. There we go. Okay, that's the first bit done. Alright, so now the next step, we've figured out a, so a is 2, but we can't go any further with substitution because there's no x value that will make my quadratic factor equal to 0. Well, not when I'm working with real numbers anyway. So what I'm going to do now is I've gone as far as I can with substitution, so we're going to start to equate coefficients. So equating the x squared coefficient, well, look on that left hand side, there isn't any x squared term, so its coefficient is 0. We've got 0x squared there. And then over here we've got 3ax squared plus bx squared. So there's my x squared term in there, and there's my x squared term in there. So that tells me that 0 is equal to 3 times 2. 0 is equal to 6 plus b, so b is equal to negative 6. And now we're going to do the same thing with the constant. We're going to equate the constant terms. Right, so what do we have? We have negative 6 is equal to, let's see, I've got a times 7, so 7a, and here my constant term is coming from negative 4 times c, so my constant term is minus 4c. Substituting in, we don't know c, but we do know a. We've got negative 6 is equal to 7 2s are 14 minus 4c. Let's pop up here and solve that. We get negative 20 is equal to negative 4c, and c is equal to 5. Okay, so we found our a, b and c, but it would be a shame to leave it like that. So on the next slide I'm just going to write out the answer nicely, which is what you should also do in the exam, or depending on what you've been asked to do. If you're told to find a, b and c, it's fine to leave it at this point, but usually you'll be asked to write it as the sum of partial fractions, and you haven't done that quite yet. Okay, so going right back to the start, we've got 29x minus 6 over x minus 4 times 3x squared plus 7. And now we just pop in our a. A was 2. 2 over x minus 4 plus b was, what was b? Negative 6. Negative 6x, and c was 5. So we could leave it like that. Now that looks actually quite ugly because by now we're used to this pretty strong convention that we don't write a linear factor like that. So I'd like to clean that up again and write it like this. Okay, that should make you much happier. There we go. So that's the answer to that one. So now what we've done is we've gone through in these 5 videos all of the mechanics of how to write expressions using partial fractions. The next step is to combine that with what we know about doing binomial approximations. So the next series of videos will teach you how to take an expression like this one here, to write it using partial fractions like this, and then to use those 2 partial fractions to do a binomial theorem approximation. Okay, so we're going to be linking those 2 skills together. Thanks for watching. See you soon.